Hello students, today we are going to have a discussion on parallelograms standing on same base and between same parallels are equal in area. So first of all, let me draw a figure. So regarding this theorem, what I found in most of the students is when the figure goes like this, then it's okay, you can easily prove it. But when some part of the triangles get overlapped, then you feel a lot of difficulties to prove the theorem. So today I'll try to make you to prove such overlapped figure in an easier way. So let's continue it. So here, so what you need to do is, so when I shape this triangle to right hand side, then you just carefully watch this. So first of all, let's watch these extremities points C, F, E and A carefully. So when I move this triangle to right hand side, what you see is the C, so it remains constant. In here previously it was F, and just now also it's F. Similarly, so regarding E, so previously also the end point was E, and just now also it's E now. And lastly here A, so here we can see the A has remained fixed. So what is the change that we have seen here in the figure, and that's you find here is previously it was dV, and now when I shape this triangle to the right hand side, then you get the dV has changed into BD. So this is the only one change that you find when you shape this triangle to right hand side. So here what we are going to do is, while proving, so you just draw a rough figure by separating the triangles, because most of you feel easier to prove the theorem when the triangles are very separate. So here just you make a figure in which they are separated. So when you draw, then you can keep the end points constant and just interchange the name of the points here. So if it is dV, then put it BD. So in this way you can easily prove this theorem. Just now I'll show an example. So here what I've done is, just I have changed here D and E. So in place of E I have put here D, and in place of E that's D. So in this way I have just made a simple change, and you can do it in your rough work. Now first of all, let's write the given conditions that are given here. So the given conditions are, so parallelogram ABCD and another parallelogram ABEF. Lie on same base. So this is the base here, AB, and between same parallels, so AV and FC. So this is our given condition. So now to prove, so here what we need to do is, we need to prove the areas of parallelogram are equal. That means area of parallelogram LCD is equal to area of parallelogram ABEF. So this is the thing to be proved. So now proof. So now here what we are going to do is, first of all, we are going to prove that these two triangles are congruent to each other. So for that purpose, we are taking triangle ADF and triangle BCE. So let's write here. So here you can see in this figure, so it's an F-shaped line here. So here AF and B, they are parallel to each other. So you can see here, so this angle is equal to this angle. So here that's AFD is equal to BEC. So these two angles are F-shaped angle, which are corresponding angles. So let's write it. So the reason is, being corresponding angles, and why they are corresponding, because here we can see AF is parallel to BE. So right here AF parallel to BE. So now let's move on B, statement B. So here just take another line, another pair of line AD and BC. So if you take your AD and BC, they are also parallel to each other, and you can find same sort of F-shaped angle. So they are corresponding angles. So here we write here angle ADF is equal to BCE. You can see here, so angle ADF is equal to BCE. And why they are equal? Because they are corresponding angles between AD and BC. So now lastly we need a side to show they are congruent to each other. So let's take a side here. You know, the opposite sides of parallelogram are equal. It means we can say AF is equal to BE. So let's write it here. So the reason is, being opposite sides of parallelogram. So now we can say here these two triangles are congruent to each other. So the reason is, from AS axiom of congruency. Now we know the congruence triangle means the triangles having same shape and same size. It means they are equal in area. So we write here area of triangle AFD so is equal to area of triangle so BEC. And for this, the reason is, being areas of congruent triangles. Now let's move on statement 4. So here what you normally do is you normally add this trapezium, small trapezium in both of the triangles. But here, instead of adding the trapezium, here what we will be doing is we take whole figure ABCF and we will be subtracting these two triangles from that figure. So we write here area of trap ABCF, so minus area of triangle FD is equal to area of trapezium ABCF minus area of triangle BEC. So here we have subtracted the equal quantities from same quantities, so we just write here subtraction axiom. So just writing subtraction axiom is enough for this. So lastly, so let's see what happens when we subtract this triangle. So if we erase it, then you can clearly see you get the figure ABCD. So here we'll be writing area of parallelogram. So what we have obtained here is ABCD. So we write here ABCD is equal to area of parallelogram. So if you subtract this triangle, then you get ABEF. ABEF. So it's whole part axiom. So lastly, you'll be writing here hence proved. Write the conclusion too. So in this way, if you draw your figure by your own self, then you can draw such figure. But if it is given in the question, if the figure is given in the question in such a way, then that figure also can be separated and made as similar figure that you have studied in your book. So here, so all the processes are similar, you have seen here, no need to change anything. Just what you need to do is just you change these two names only. So in place of ED you put here D, and the remaining will be same, so nothing is changed. So in this way you can do this overlapped figure in easier way. I hope you enjoyed the video. It will be fruitful for you too. Now catch you soon in the next video. Bye for this time. See you.